Hello, it's Keith here, and this is lesson 28 of the simple series of my Z80 assembly programming tutorials, and we're continuing with our sprite clipping, and today we're going to do sprite clipping on the Sam Coupe. If you've not seen the rest of the series, no reason why you should have done, but basically we had previously an example where we were showing a bitmap graphic on the screen of our Chibiko mascot, which you can see here in a rather strange colour, and we could move it around the screen before, but we couldn't go off the screen. Well, now we can indeed, if I use the right keys, go partially off the screen, so you can see that the Chibiko bitmap is now cropped if we go partially off the screen, and we can crop on all sides of the screen. So we're getting closer to something like you would need for a game, like a scrolling game. This cropping code you're seeing today is based on the Suck Shoot game, which was a scrolling stereoscopic shooter, a bit like Operation Wolf, and I modified it because that only scrolled horizontally, and so this crops horizontally and vertically, and that's what we're going to be looking at today. Now, the reason the colors are a bit odd is because this is using an XOR routine, so it's inverting, and I've set the background to a green so that we can see the area of the actual working screen. There were a couple of tricks going on as well as the cropping, though. We are using stack misuse to clear the screen quickly and to read in bytes quickly. We're also using two screen buffers so we don't get any nasty flicker when we're moving around. We're going to look at this example in two parts. The first one, we're going to look at the clipping routine and the new bitmap drawing routine, and then the second one we're going to look into the way that we do the double buffering and also how we do the stack misuse to read quickly and also clear the screen. So we'll split it up into two parts. Now, if you've seen these tutorials before, you know that we need to go over some theory first before we discuss the actual code. So let's go over here and let's take a look. Now, the first thing we need to discuss is how I work with the coordinates. Basically, the Sam Coupe screen is 256 by 192, which is a nice big screen. It's a nice 0 to 255 range for bytes, but of course, if we're going to have things partially off the screen, we need to work with a coordinate system that allows our coordinates to be partially off the screen. And so the 0 to 255 range needs to include an on-screen area and an off-screen area. And so what I do to make things nice and simple is I work in a logical coordinate system where each logical unit is 2 pixels, and this makes it very easy to work with a 320 by 240 screen or a 256 by 192 screen within a 0 to 255 range. And it also makes calculation nice and easy because we know everything. We just need to double it to convert logical to pixels, or halve it to convert pixels to logical. Now, this is going to, of course, allow us to do clever things like have our Chibiko, like this, where the coordinate for the top left would be here, but the Chibiko is only partially on the screen, and it's only this light part which is actually going to be drawn. And it's the cropping routine that is going to do those calculations and work out which bits need to be drawn and which bits don't. So let's just go over to the blackboard and let's discuss the theory of how we do our cropping. Let's just quickly discuss it. So we've got our screen area, whatever resolution it is on the system we're working on, and we've got our sprite. There's our sprite. And our sprite will move happily around the screen until it gets to a border. And of course, when it's all on the screen, we can just draw things pretty straightforwardly in the exact same way we did before. But when it goes off the screen, we're going to have to recalculate things. So if it's gone off the top of the screen, well, we're going to have a bitmap source data, and we're going to need to skip part of that source bitmap data because the top doesn't want to be drawn anywhere. And then what we're going to do is we're going to change the height to the remaining part, and we're going to change the draw top to 0 because this would be a negative value, and we can't draw to a negative value, so we don't want to do that. So that's how we're doing the top crop. The bottom crop, we would just change the height because we don't need to skip any of the source bitmap data, so we just change the height. If we go over the left hand side, a little bit tricky here though, we would change, of course, the X position to 0, we would change the width to this amount, and we would skip part of our source data here. The way that I'm drawing these sprites to the screen is a bitmap transfer, of course, and we're going from left to right, top to bottom in a zigzag format like that. So we would skip this first part before the first line, but then after each line we would need to skip the next part here after each line. So that's two things we're going to have to do there. Now that's on the left hand side of the screen. Of course, on the right hand side of the screen, well, we're going to need to change the width again. We don't need to skip any of the first bytes because we're showing the top left, but after each line we still need to skip this part here. Tricky thing, of course, is there's no reason that our sprite is just going to need one kind of crop, because it could be in a place that needs two kinds of crop, and that could get a bit tricky, but this code can do that. And the reason I stipulate that this code can do that is because the Chibiakuma's code could not do that. And if you look very carefully, in the few cases where there were sprites in the corner of the screen, they were getting corrupted because the calculations didn't work. However, today they do. And so we're going to have a look at this code today, and hopefully it might be a little bit useful to you, or at least a little bit interesting. So the first thing we're doing here is we're defining some symbols, and these are defining the area of the screen in logical units. So this is defining basically the top left pixel in logical units of the first visible pixel. So the first logical unit that is going to be a drawable one is 64,80. The width and the height of the screen is 128 by 96. If you remember, logical units times 2 equals pixels. So that's 256 by 192 there in pixels. Now, we've got this use stack misuse parameter here, which we can enable, and then this will actually compile some alternative code, and this is going to use stack misuse to quickly read in the sprite data. And the reason we've got this disableable is so that we can see the difference. And the difference is going to be, well, it gets a little bit jerky when we go off the left hand side because we're having to work in pairs of bytes. Now, when we go off the right hand side of the screen, you'll notice that every other line we've got a little bit of our sprite is missing, and the reason for that is we are now working in pairs of bytes, and that's because of the way that the stack misuse is working. But we'll discuss that more next time. Now, what we're not going to discuss is the basic code. A lot of the code here is the same as the previous simple series example of the joystick reading and the sprite drawing, the bitmap drawing. So please take a look at those if you need to know everything that's going on here, because I'm not going to repeat it all again. What we're going to look at is the new draw sprite routine and the do crop routine, which is doing all the mathematical calculations. Okay. So draw sprite starts by specifying the source bitmap data in IY. So test sprite is our bitmap, and that's being loaded into the IY register pair. X and Y in logical units is in B and C here, and our width and our height are being loaded into H and L in logical units. So this is 48 by 48 pixels, 24 by 24 logical units. And then we're running the do crop routine, which will calculate any crop. However, it will set the carry if the sprite is entirely off the screen, in which case we would want to give up. If we do want to draw the sprite, we calculate the screen position using this getScreenPos that calculates the VRAM destination, and then we run the show sprite routine to draw the sprite to the screen. And we'll have a look at that in just a moment. Okay, so let's take a look at this do crop routine here. So this is going to handle the cropping of our sprite, and I have my little sprite stick here. So this is our sprite, and we're going to discuss how we will deal with cropping it as it goes off the various sides of the screen. And the first thing we're going to do is we are going to set up the cropping routine that handles the left and right crop. And this is going to remove bytes from each line. We're going to disable it, so we're assuming that nothing needs cropping off the sides, because mostly it won't. We're then setting D and E to 0. These are our temporary variables used over the next stages for calculations. What we're doing here is we are loading the Y position in logical units into the accumulator, and then we're subtracting the minimum visible Y position. And this is effectively going to go negative if our sprite is somewhere off the top of the screen like that. Now, if it hasn't gone negative, then there is nothing to crop off the top. So we're skipping the next section. But if it has, we're converting that negative to a positive, and this is now the amount we need to remove from the top. We're seeing if it's the entire height of the sprite, and if it is, then we are jumping to all off screen. All off screen does is it sets the carry and it returns, and that's telling the calling routine, give up, there's nothing for you to do. So it's going to save us some time and also stop us drawing a sprite of 0 height, which might cause us an infinite loop of some kind. Okay. So if the sprite isn't entirely off the screen, we're now storing the amount to remove from the top in the E register, and we're setting the Y position to 0 here, because we're going to draw from the very top. C is going to be updated here, the Y position. If it's not being cropped off the top, then we still need to remove the invisible area, so that subtraction is still important. We're going to convert it to a number of lines later on at the very end, but what we're going to do next is we're going to consider the bottom of the screen. So we're adding the height of the sprite, and what we're going to do now is we're going to see if the sprite is partially off the bottom of the screen like that. That's what we're doing here. So we are then going to subtract the height of the screen and then see if that has caused a carry. If it has caused a carry, then we are clearly not off the bottom of the screen. Otherwise, if it has, then the amount that is left is the amount we need to remove from the bottom of the sprite. And so we are comparing this to the height again and seeing if we are entirely off the screen. And if we're not, we're storing that in D. So we've now got the two parts for cropping the sprite vertically. So we are taking the amount to remove from the top, adding the amount to remove from the bottom, and if the two together are non-zero, then we need to remove something. And so what we're doing is we're negating it, we're adding the height of the sprite, and we're now updating the height of the sprite. So the height of the sprite has been changed for any top and bottom crop. What we need to do next, though, is we need to actually remove any source bitmap data from the top of the sprite. Because remember, if you think of the head of this character here, well, if the sprite is off the top of the screen, we need to skip that head. So that's what we're going to do here. So what we're doing here is we have loaded the accumulator with the number of lines in logical units to remove from the top. We're then calculating the number of bytes to remove for each line, and we are doing that just by loading this in here, because of course there are actually 2 pixels per byte, and this is in logical units, which is 2 logical units per byte, so it works out quite well. And we've just got a very crude multiplication here, which is repeatedly adding DE to IY until the line count goes to 0, and so this is effectively removing those source bytes from the top of the bitmap for when we're drawing to the screen like that. Okay, so we've now calculated the top and the bottom crop. We're now going to do the same for the left and the right. So what we're doing here is we are setting D and E back to 0. We don't need the old values anymore, and we're going to do the exact same thing. So we're loading in the X position, subtracting the minimum X screen location. If that's gone below 0, then we have an amount we need to remove from the left hand side. And so what we're doing is we're negating that, converting it to positive, comparing it to the width of the sprite. If it's the entire sprite, nothing's on the screen again, because of course it could be entirely on the screen in a vertical axis, but entirely off the screen in a horizontal axis. So we do need to check both. So that's what we're doing there. We are then updating the amount we need to remove from the left hand side in E here, and we are setting our X position to 0 for the left hand side. Right hand side, again, exactly the same. We are now adding the width of the sprite, subtracting the width of the screen. If this has caused an overflow, then we aren't partially off the right hand side of the screen, but otherwise then we must be partially off the side of the screen. So we're seeing if it's the entire width of the sprite. If it's not, we store the result in D. Okay. So we added the 2 amounts to remove from the left and the right of the sprite together here. We've then got a line that only works on the stack misuse, and this is basically rounding into a number of pairs of bytes here, because if we are using stack misuse, we have to work in pairs of bytes. Now, as I said before, after each line of our sprite, if we're off the left-hand side or the right-hand side, we're going to need to skip some bitmap data before we draw the following line. And so we are updating via self-modifying code this sprite h clip value here. The +2 -2 is a calculation because we're modifying a line of code which we'll see in just a moment. So this is self-modifying code, so the variables are in the code itself. We're then updating the width of our sprite here. We are loading the old width, subtracting the new combined width, and we're updating the width here. And then the last thing we're doing here is we are going to update the start byte, and we'll effectively skip any of the first bytes before we draw the first part of our image to the screen. So we're loading in the amount to remove from the left into the accumulator here. This now frees D and E up, and so we're now modifying in this alternate version of the get next line routine here via self-modifying code again. You're going to see that in just a moment as well. And we're then again rounding up to a pair of bytes here that we need to remove from the left hand side. We're then adding that to IY, our source bitmap data. We're now done all of our cropping, and the final things we want to do is we need to convert from logical units to physical. Now, horizontally, there are 2 pixels per logical unit, and there are 2 pixels per byte. So logical units and bytes are actually the same thing horizontally. Vertically, we want to convert to lines. So we're effectively doubling the height and the Y position, and this now has our coordinates as we want them for the calling routine. We OR here just to clear the carry, and then we return. So that's our cropping routine that we're using here. Now, there are 2 versions of the sprite drawing routine here. One for stack misuse, which we're going to look at next time, and this one here that doesn't use stack misuse. Now, the first thing we're going to need to do is we're going to page in the memory that we need to actually have for the VRAM. So we're going to page it in to the low memory range, which is the 0 onwards range here, using the port 250. Now, this is basically the 0 to 7FFF range. Our program is running at 8000 onwards, so that's not going to cause us any problems. But what we do need to do is we need to disable interrupts first. Now, active buffer will be changed later on. We're going to look at that next time in the episode where we discuss the page flipping and the double buffer and things. So that's what we're going to look at then. Now, we are moving IY into DE here, just for convenience, because DE is going to be faster. And here is our main loop. So we're loading in the width of the sprite, which is now in IXH here. And we are then going to transfer bytes from our DE source to our HL screen memory, XORing them with the current values on the screen, and we're going to repeat until we've done an entire line. Now, we calculated our screen address with the get screen pos routine. Where's that? It's not changed since last time, but just for completeness. So here it is. So basically all we're doing here is we're effectively multiplying the Y position by 128 and adding the X position. The screen base is 0, memory address 0, so we don't need to do very much for that. And then basically all we need to do after each line is we need to move down a line. Now what we're doing here is we're jumping to this get next line routine, but you'll notice that there's this weird calculation after that, and this is used by the self-modifying code, because if we want to crop the lines we need to do some extra work, and so rather than have a condition in here, we're self-modifying this jump to a different place. So the get next line routine, the basic one, just adds 128 to the VRAM destination, effectively moving down one line, increasing H if L is overflowed there. But if we need to crop our sprite horizontally, if our sprite is partially off the left or partially off the right, well, we need to skip some bytes, and that's what we're going to do just here. So we've got HL loaded with 0 here, but by the time this runs, it will have been modified, and that 0 will be a different value because of that line there. And that calculation of subtracting 2 is so we get the low byte of that HL pair. So HL will be the amount we need to clip. So adding HL and DE together and switching the value back into DE. And this is adjusting our source bitmap data so that we've missed any bytes that we don't need. Now, there's a jump get next line here. This should actually be remmed out, really. For completeness, I like to have it there, but it should be remmed out because, of course, it is the next neighbouring line, so that's a waste of performance there. But basically, this allows us to crop our sprite, and as I say, because we're using self-modifying code, we've reduced the number of conditions, and we've saved a little bit of memory by not having any variables in other places. So there you go. So that is the example that you can see here. This is the non-stack misuse version. We will look at the other version next time, and as I say, it's perfectly adequate for a simple cropping routine, and as I say, you can go to my website and download the source code and the build scripts, and you can have some fun with it and do whatever you want with it. And as I say, if you somehow manage to use it in a commercial game, I doubt you can. I don't think it's that amazing, but you're welcome to do so if you somehow achieve it. Anyway, next time we're going to have a look at the more advanced stuff, how the double buffering works and how the stack misuse works. So if you liked what you saw, please like and subscribe so you see that next one. Anyway, I hope you've enjoyed what you saw today. Thanks for watching, and goodbye.